My experiment is the methylene blue traffic light, and for this experiment you need a 500 milliliter Florence flask with a stopper. You need 300 milliliters of water. You need 10 grams of dextrose and 8 grams of potassium hydroxide, and then a methylene blue indicator. And the first step you do is you dissolve 8 grams of the potassium hydroxide in 300 milliliters of water, and you do that inside the 500 milliliter Florence flask. And then just shake it to dissolve it. And then next you're going to add your 10 grams of dextrose to it. And then dissolve that. And then you're going to add 6 to 8 drops of the methylene blue indicator, and I just use 7 because it's in the middle. And then you shake this and let it sit until it becomes colorless. And then I already made another one to save some time that's already colorless. And then what you do is you just shake it and the blue color should reappear. And then you can do this as many times as you want until all the oxygen in the flask is used up. After it settles, you can shake it again. And the reason that this happens is that by shaking the flask, you reintroduce oxygen into the solution, so that causes the methylene indicator to turn blue. And then when you let it sit, the dextrose reduces the oxygen in the solution, so it causes it to turn colorless again. And the reaction that takes place is called a redox reaction because it has reduction and oxidation both happening at the same time. And the reduction is the loss of oxygen that occurs when the dextrose takes oxygen out of the solution. And then the oxidation occurs when you shake it and it turns blue because oxygen is reintroduced into the solution. Oxidation occurs in many real-life examples. Examples of this is when an apple turns brown, when metal rusts, or the green color on the Statue of Liberty. In the example of the apples contain an enzyme that reacts with oxygen that causes it to turn brown when it's cut open. Certain metals react with oxygen to cause them to rust. And the green color on the Statue of Liberty is caused by the reaction of copper with oxygen that causes a patina, which is the name of the green color. And this knowledge can be used in real life, for example, to stop problem oxidation from occurring. So an example would be if your car rusts, you can use this knowledge to stop it by putting a coat of wax on your car, because the wax does not react with the oxygen the same way, so it will stop the oxygen from getting to the metal that reacts and causes rust. And a good way to see this is here with this equation. Indicator A is the original solution, and it reacts with oxygen, so if you go to the right it causes it to turn blue. So that is your oxidation, and then when you go back the other way it's your reduction because you get your indicator A and your oxygen again. And then these are my references.